In this video, we are just going to work through our practice exam for exam 1 for our business calc class. So number 1 says the graph of y equals f of x is shown above. Evaluate each limit or write does not exist if the limit does not exist. No justifications are necessary. So for part A, we have the limit as x approaches -4. So we go to x equals -4. We look for the point where it's touching on the function, and we see if the function is approaching the same point from the left and from the right. Here the function is approaching the same point from the left and the right. Remember, the limit does not need to, for the limit to exist, we don't need the value of the function to be at that point. The limit as x approaches -4 is going to be exactly y equals 6. For part B, we have the limit as x approaches 10 from the negative side, so from the left. So as x approaches 10 from the left, that's going to be approaching 10 from the left right here. As we approach 10 from the left, we're going up towards infinity. Part C is the limit as x approaches 2, so we're done B, we're on to C. The limit as x approaches 2, and so we go to 2. And we see that the function is approaching the same point from the left and right. It looks like that point is about 1, so we'll put a 1. The limit as x approaches 2 of this function is 1. For part D, the limit as x approaches -2. Well, from the left, x is approaching -2. The limit as x approaches -2 from the left is going to be 2. But the limit as f approaches -2 from the right is actually going to, it looks like -1. And so this one does not exist. For part E, we have the limit as x approaches 6 from the positive side. The limit as x approaches 6 from the positive side. We have the positive side over on the right. And the limit as x approaches 6 is going to be exactly 2. For part F, we have the limit as x approaches 6 from the negative side. As x approaches 6 from the left, we are approaching y equals 4. For G, it says, for f of x to be continuous at x equals -4, we must set f of -4 equal to something. Well, we have a removable discontinuity. That removable discontinuity is right at y equals 6, so we need f of -4 to equal 6. Essentially what that does is that fills in this circle here. For part H, we have estimate the derivative f prime of 0. So at 0 here, it looks like our derivative, it looks like we have a pretty linear function. So our derivative is going to be just the slope of this function, and the slope of this function at 0 is something like, well, when we're at -2, we're at -1. So we have the point -2, -1. When we're at 2, we're at 1, so we have the point 2, 1. To find the slope real quick, we have y2 minus y1 over x2 minus x1. 1 minus -1 is 2. This is equal to 2 over 2 minus -2 is 4. We're about at 1/2 or 2/4. So our slope is a half. Part I says estimate the derivative f prime of 4. When we're at 4, it looks like our slope is about 0. So our derivative is about 0. And then J says estimate the derivative f prime at 12. At 12 here, we have the function is curving, so it's a little tough. It's not going to be 0. But we have this line coming off of the function, and we need to estimate the slope of that line. We know it's negative. We know that we're going from 4 down to about 1. From 4 down to about 1 as we span from 10 to 14. And so I would say we have a slope of maybe -3/4. -3/4. And that's all that one's asking for. Problem number 2 asks us to evaluate the given limit and write a positive infinity or negative infinity if it's an infinite limit. If it does not exist, we'll just write d any and move on. So for part A, We need to know if the discontinuity at x equals 3 is going to be removable, in which case we'll have a finite limit, or if it's infinite. And to figure that out, we just have to factor the top. Two things that multiply together to equal 24, but subtract to equal 11. Let's think about that for a second. Sorry, they should add up to equal 11 because we need a positive sign here, so two negative numbers. So 3 and 8, x minus 3, x minus 8. And then look at this, we have an x minus 3 on top and x minus 3 on the bottom. So this is equal to the limit as x approaches 3 of just x minus 8. And if we plug 3 in, we get negative 5. So that's our answer for that one. For part B, we have the limit as x approaches negative 5. Well, we'll do the same thing. We'll factor the top and the bottom. Here we have a negative sign, so we need two things to subtract to equal 1, but multiply together to equal 20. So I have x plus 5, x minus 4. And on the bottom, we have x plus 5, x minus 5. Yeah, so we can cancel the x plus 5s, and we get the limit as x approaches negative 5 of x minus 4 over x minus 5. Which again, we can just plug negative 5 directly in. On the bottom, we get negative 10. On the top, we get negative 9. So we get positive 9/10. For part C, we have the limit as x approaches 4 from the negative side. So the limit as x approaches 4 from the negative side. If we plug in 4, we get 1 over 0. So we have a problem. We're going to have something that gets really small in the denominator as we approach 4. And so we're going to have a really big number. But we just have to figure out if we're going to be approaching infinity or negative infinity. So if I plug in, say, 3, I get 1 over 9 minus 12, which gives me 1 over negative 3. If I plug in something like 3.5, I'm going to have bigger than 9 but less than 12. And so the denominator is going to get smaller but stay negative. If I plug in 3.9, it's going to stay negative. And so we are going to have the limit as x approaches 4 from the negative side, or from the left in this case, is going to be negative infinity. We're going to get a really big number in the denominator with a negative sign. Part D, we have to remember our horizontal asymptotes. We have two pieces here that seem to be the dominating terms. As we go towards infinity, those are really the terms that are going to matter. They have the same power, so we can cross off, we can cancel our x to the 6's. And we're left with the limit just being negative 5 over 4. And that's all. Problem 3 says, here's the definition of the derivative. If f of x equals 5x to the third, write the limit for f prime of 2. Do not evaluate this limit. So we have f prime of 2. Here, 2 is going to be a, is equal to the limit as h approaches 0 of f of 2 plus h minus f of 2 over h, which is equal to the limit as h approaches 0. F, in this case, is 5x to the third, so we get 5, 2 plus h to the third, minus 5 times 2 to the third over h. Part B says show that g of x equals the absolute value of x is not differentiable. Evaluate this limit. Let's plug it in directly to our limit definition above. So I have the limit as h approaches 0 of f of x plus h minus f of x over h, which in this case is equal to the absolute value of x plus h, minus the absolute value of x all over h. Now we see that x here is going to be 0, so let's plug that in, and we get the absolute value of 0 plus h, absolute value of 0 plus h minus absolute value of 0 over h, which is equal to the absolute value of h over h. And then we can see what's happening here. As h gets really small, it doesn't matter because we have h over h in the positive direction. So when we're positive, if we have like 1, 2, 3, 4, 5, no matter what, we're going to get a 1. But if we're negative, if I have like -6, I'm going to have a positive number on top because we have the absolute value of a negative and a negative on the bottom. But it's still h over h. It's just h over negative h. And so when we're to the left, we're going to go this way. And so we actually have a jump discontinuity right at 0 of the derivative of this function. And so we see that it's not differentiable at that point because the limit does not exist at 0. Problem number 4 says on the grid below, graph the piecewise function. So we have 3 minus 2x when x is less than 2. So let's plug in x equals 2. We get 3 minus 2 times 2. 3 minus 4 is -1. So when x equals 2, we get -1 with an open circle. This is clearly going to be a line, so let's just plug in x equals 0, and we get 3, and so we get the line going this way. When we're greater than or equal to 2, we have, let's plug in 2 again to this function. 2 minus 5 is -3, so at 2, we're at -1, 2, 3, with a closed circle. And then I can plug in 3. 3 minus 5 is -2, so we're going to go up. I could plug in 4. 4 minus 5 is -1. I could plug in 5 and get 0. We go up in that direction. And the question is the function continuous at x equals 2? Right here we have x equals 2. The answer is clearly no. Problem 5 says for what value of c is the function continuous at 3? Justify your answer. So it'll be continuous at 3 if our functions 8x minus 4 over x squared plus 1 is equal to x squared minus 4x plus 5 exactly at that value for c, exactly at 1 point. So if these two functions are equal at the point 3, then we're good. Let's plug 3 in. 8 times 3 minus 4 over 3 squared plus 1 equals 24 minus 4 is 20. 9 plus 1 is 10. So on the left, we have a 2. On the right, we have 3 squared minus 4 times 3 plus 5. 3 squared is 9 minus 12 plus 5. 9 minus 12 is -3 plus 5 is 2. So in order to make this continuous, c just has to equal 2. Essentially what we have here at the point 3, at the point x equals 3, is some function with an open circle, some other function with an open circle, and then c is going to fill that circle in. Problem 6 says to compute the derivative. So for part A, we'll move pretty fast. We have 5x to the 4th over 3 minus, we have 3/4 times 4x to the -1/4. Remember, we subtract 1 in the exponent and we bring down the exponent. Plus 3, the 8 turns into a 0, and then we get plus 15 over 3 with a negative sign. X to the 1/3 minus 1 is -4/3. Part B, I have all these roots. I'm going to fix the roots first. I'm going to say this function, so this was y prime. For part B, I'm going to fix this function first before I differentiate. I'm going to say this is 7x to the -1/3. An x to the 3rd root in the denominator is an x to the 1/3 in the denominator, which is an x to the -1/3 in the numerator. Minus 6, x to the 9/2. Remember, the square root is a half a root, is a half a power, I mean. Plus 12x to the -1 plus 4x to the -7. If I didn't do that, I would have a lot of quotient rule, which is more challenging. But in this case, I can now take the derivative and get y prime is equal to negative 7 over 3 x to the negative 4 thirds minus 6 times 9 halves x to the, if I subtract 1, 1 is 4 halves. I mean, 1 is 2 halves. And so 9 minus 2 is 7 halves plus negative 12 x to the negative 2 plus negative 4 times 7 is 28 x to the negative 8. And that's what we get. We don't have to simplify, so we'll continue. The derivative of c here, c is 2x to the 5th minus 3x squared minus 2 to the 1/3. Here I can use the chain rule, and I can say the derivative of the outside, so y prime is equal to, the derivative of the outside is 1/3 times the inside, 2x to the 5th minus 3x squared minus 2. The derivative, when we have something to the 1/3, we subtract 1 and we get negative 2/3. And then it's just that times the derivative of the inside. The derivative of the inside here is just the derivative of this inner piece, which gives me 10x to the 4th minus 6x. The 2 goes away, so we don't have a minus. And that's our chain rule. For part D, I need to use the quotient rule. The quotient rule is low D high minus high D low all over low low. That's how I remember it. And then we just plug in. So in this case, we have low is x to the 6th minus 2. D high, the derivative of the high function, is going to be 6 times 4 is 24. X to the 3rd plus 15x squared minus high D low. I'm going to have to go on to the next line. Sorry if this is ugly. But minus high D low is 6x to the 4th plus 5x to the 3rd times the derivative of the lower function, which in this case is just 6x to the 5th. And that's all going to be over just low squared, x to the 6 minus 2 squared. For part E, we really have two options. We can either do the product rule or we can multiply this out and just use a bunch of power rules. The easiest thing to do is the product rule, so that's what we're going to do. The product rule is the derivative of the first function times the second, plus the derivative of the second times the first, which means we have the derivative of the first function, which is 15x to the 4th plus 16x to the 3rd times the second function, which is 4x to the 7th minus 18, plus the derivative of the second function, which is just 28x to the 6th, times the first function, which is 3x to the 5th plus 4x to the 4th, no minus 2, that goes away. And that's our derivative. Continuing, we have the derivative of this function here, which can be rewritten as 3x plus 2 to the 4th power minus 15x, all to the 1/2. And once I see that it's to the 1/2, I see that I'm going to do the chain rule. The chain rule is the derivative of the outside, which is just 1/2. This was y prime equals, sorry, I should be writing this everywhere. This is y prime equals, this one is going to be y prime equals. The derivative of the outside, which is 1/2 multiplied by the inside, to the negative 1/2. A half minus a whole is negative a half. And then this is going to be multiplied by the derivative of the inside. So I'm going to start some parentheses here. And the derivative of the inside, this first piece, the derivative, we need to use the chain rule, which is again going to be the derivative of the outside, which is 4 3x plus 2 to the 3rd times the derivative of the inside, which is just 3, minus 15. And that was the derivative of the inside, and that's our derivative. We got a nested chain rule in this one. Cool. Problem number 7 says, the graph of y equals f of x is shown above, where x is between -6 and 6. For which values of x is f of x not continuous? We just look for points where we would have to pick up our pen if we were drawing this. So that's specifically at -2, we see a hole. At 2, we see a hole. And it looks like that's it. So -2 and 2. B says, for which values of x is f of x not differentiable? That would be at these points, at these hard points. If you were being a stickler, you could also say that it's at the edges, because at the edges, we don't have, for example, at -6, I don't have a left-hand limit. So the left hand and the right hand limits are not going to agree. And so we're not going to have continuity. We might say that we are differentiable. We'll ignore the edge cases, but we could say that this is also -6 and 6. For part B, we have for which values are we not differentiable. That's going to be at the peaks and valleys. So here we have a pointy spot. Here we have a pointy spot. That's at -5, -4. Also at -2 at those jumps. At 2. Also at 0, we're not differentiable because we would have that the derivative, we have a vertical thing happening here. So at 0, we're not differentiable. We wouldn't get a value for that derivative. Notice at 4, we have a valley, but the valley is smooth. It's not pointy, and so we are differentiable there. The derivative there is just 0. And so that's our list. Part C says, for which x values is the derivative equal to 0? Well, that's going to be at 4. And it looks like that's it. Yep. Okay, that's that problem. Problem 8 says, here is a function. Let the equation of the tangent line to the graph of f of x. Find the equation of the tangent line of f of x at x equals 1. So we know that x equals 1. If I want to find y, I can just plug in x, which gives me 3 times 1 minus 2 times 1 minus 10, which is 3 minus 2 minus 10, which is -9. And now if I want to find the slope at 1, I need to take the derivative. F prime of x is going to be 9x squared minus 4x minus, not minus 10. The derivative of a constant is 0. And so we have this, and then we have at x equals 1, f prime of 1 is going to be 9 minus 4, which is 5. So we have m equals 5. Well, now we just have to find b. Y equals mx plus b. -9 equals 5 times 1 plus b. Subtract the 5 to the other side, we get -14 equals b. And so our answer is y equals 5x minus 14. Cool. Next up, we have a function g of x. We're finding g prime of 0. So we need to find g prime. G prime of x is going to be, this is a chain rule. We're going to get 6. The outer function is 6 times 2x minus 1 to the 5th. The inner function is times 2. The derivative of the inner function is 2. And when we plug in 0, we have g prime of 0 is equal to 6 times -1 to the 5th times 2. -1 to the 5th is going to be -1. You can multiply that out and test it, but even powers would give you a 1. Odd powers would give you a -1. So we get -12. Part B says find g double prime of 0. Well, g prime of x, let's make it look nice, was 12 times 2x minus 1 to the 5th. So g double prime of x is going to be, bring down the 5. 5 times 12 is 60. 2x minus 1 to the 4th times the inner function's derivative, which is 2. And so G double prime of 0 is going to be 120 times negative 1 to the fourth, which is 120, positive 120. Awesome, almost there. Problem number 10 says, for X units sold, we have a revenue function and we have a cost function. Find the profit function. Revenue is all the money you brought in. Cost is all the money that cost. Profit is the difference between the two. It's the revenue minus the cost. So let's figure that out. Let's do R of X minus C of X, which is going to equal P of X. All the money we brought in minus everything that it costs to get there is going to be R of X minus C of X. 30X minus 8X is going to be 22X. This is P of X is equal to 100 minus 500 is minus 400. And then 1/8 x squared is just 1/8 x squared. So that's our profit function. And we're asked to find the marginal profit when 100 units are sold. Our marginal profit is just the derivative of the profit, the change in profit, which is P prime of X, which is 22 minus 1/4 X. That's the derivative of P. Take a second and do that if you'd like. And if I plug X equals 100 in, P prime at 100, I'm just going to get 22 minus 1/4 times 100 is 25, which is negative 3. And so we see that our marginal profit is negative 3, which means our profit is reducing as we go above 100, which is interesting. Part C says if P of 100 is equal to 550, use your Part B answer to estimate the total profit of 101 units. And there's no trick here. The answer to this question is just going to be if P is 550, then we have 550 minus our 3 is going to be 547. And so the question is, should the company sell the 101st unit? The answer is no. And the reason they shouldn't, I'm not going to write this all out, but the reason that we shouldn't sell the 101st unit is because our profit is going to go down as we make more units. We've passed our positive profit direction. And that's our review sheet.